Hey everyone! Today, we're diving into a game-changing discovery in electronics manufacturing, a new technique for growing metal nanowires that could revolutionize the production of advanced electronic components. Get ready to learn how this breakthrough from Nagoya University could transform industries like LEDs, solar cells, and optoelectronics. Welcome to Trend Storm. Chapter 1. Nanowire Technology Breakthrough. So, what's the big deal about nanowires? These tiny metal structures are crucial for next-generation electronics. But up until now, the mass production of nanowires has been challenging because of the difficulties in maintaining quality and purity while scaling up. Without a reliable production method, their use has been limited, until now. A research group led by Yasuhiro Kimura at Nagoya University has developed a new technique that promises to solve this problem. By significantly increasing the density of aluminum nanowires while keeping them pure, they've opened the door to large-scale manufacturing. This could have major implications for everything from circuits and sensors to solar technology and biomarkers. Chapter 2. Innovative Growth Technique. How did they do it? It all comes down to a process called atomic diffusion, but with a twist. Typically, creating nanowires involves moving atoms in a gas state, which can be tricky with metals. However, this team used a solid-phase atomic diffusion method enhanced by ion beam irradiation. Sounds high-tech, right? Let me break it down for you. Here's how it works. They applied ion beams to the surface layer of a thin aluminum film, causing changes in stress distribution within the crystal grains. This stress guided the flow of atoms, essentially feeding the material needed to grow the nanowires. When they added heat, the atoms flowed upward through the film, resulting in a massive growth of nanowires. Chapter 3. Breakthrough in Nanowire Density. And here's the big news. Using this technique, the researchers boosted the density of aluminum nanowires from 2 × 10⁵ to a staggering 180 × 10⁵ nanowires per square centimeter. That's a huge leap forward in nanowire production. Even more exciting? This method doesn't just apply to aluminum. In principle, it can be extended to other metals, opening up endless possibilities for advanced electronics and nanotechnology. Chapter 4. Potential Applications and Future Outlook. So, where can this technology be used? These high-density aluminum nanowires have a lot of potential. Due to their unique properties, such as large surface area, excellent mechanical strength, and oxidation resistance, they're perfect for sensing devices and optoelectronics. Think gas sensors, biomarkers, and high-performance nano devices for medical and environmental applications. And the best part? This new technique is scalable. With just 3 steps, thin film deposition, ion beam irradiation, and heating, researchers have found a way to mass-produce nanowires in a way that could reshape the future of electronics manufacturing. This breakthrough in nanowire technology is set to transform the way we produce advanced electronic components. From more efficient solar cells to cutting-edge optoelectronics, the possibilities are endless. Source: Nagoya University. Let us know in the comments how you think nanowire technology will impact the future of electronics. If you're as excited about this discovery as we are, don't forget to like, subscribe, and hit that notification bell for more cutting-edge science and tech updates. Thanks for watching Trend Storm, and we'll catch you in the next video.